Hi, in this video today we're going to take a look at a broken Sheffield electronic drum kit. This has no power whatsoever. Even with fresh batteries in, it is not doing anything. But it does make a weird popping sound when you go to turn it off. So I'll just show you that now. Did you hear that? There. So there is some bit of life there. So hopefully it'll be quite an interesting one. So let's take it over to the blue mat, take it apart and see if we can find out why it's got no power. Okay, let's just unplug these little foot pedals from the back here. So now, model number here is 276501. It's just a Sheffield E drum set. Now, I had a quick look online. Apparently these were sold in Lidl. So I've fitted fresh batteries to it. Let's just double check we have got the voltage. So if we were to go here and here, we should have 6-ish volts. Right, okay, let's take it apart and see what's happening. We've got a load of screws around the place. I think I want to be kind of dealing with the power switch to begin with, because I think it's going to be okay from the power going into it, because it does make that little clicking noise when you turn it off. So I think, could it just be as simple as an on and off switch? So it comes apart really easy. We just have to undo about 20 Phillips screws. Here we go. Excellent, right, so we've just got 2 wires going off to the battery terminal here, because all the screws will fall out if I turn it the opposite way. So let's unplug the battery terminal. Yeah, so red's positive and it can only go in one way anyway. Good, okay, so I don't have to worry about losing those screws. Now, what have we got here? So, on and off switch is, whoops, on and off switch is there. Hold on, the speaker just flew out. So that's the on and off switch. So let's concentrate on that to begin with. Oh look, they got the little piezo buzzers here, or piezo. So now, is this working here? Maybe not. Let's unplug this one. Okay, so what have we got here? So there's 5 contacts. The outer 2 I think are going to just be the anchor points. So it's going to be these ones here. So it must be these 2 when it's off and these 2 when it's on, or there to there when it's on. Let's see. Let's go to continuity. Okay, so that's in the off position. Let's turn it on. And that's in the on. Excellent, that's good. The switch is working, because that would have been a bit boring. Now, let's see if we can trace to see where it goes to after that. So let's take it from this side here. So it comes into here. This is the speaker. And then it goes down on this wire here, doesn't it, to this board. Oh no, but we've also got it going across here onto this board here. I think we need to pop the batteries in and trace voltages. So from here, let's see if we do have voltage going down to this area. So what have we got it on? We've got it on this one here. So ground. Yeah, we've got 6 volts there. Okay, and then when we turn it on, well, it's already on. Let's leave it off and see if we've got 6 volts here. No. Now let's turn it on. And we should have 6 volts here. We have. So from 6 volts here now, it's travelling down to this board here. So we know we've got power going into this board. Slightly worrying now because we have a blob chip here. Looks like there's another mini blob chip there as well. Oh, this is going to be the screen as well, isn't it? Yes. This is going to be the screen. Right, I'm going to take a picture of what goes where, because I need to unplug some of these. Oh, so hold on, these are not being used. These are not being used for speakers, are they? They're just noticing the vibrations, I think. So rather than, putting the signal through into this and letting this vibrate, this must be picking up the vibrations and pushing it through to here to register that it's been hit. So we definitely have voltage going into this here. So I suppose it's just going to be a case of, can we trace where that goes to? So where's the main power rail coming in? Is it this one here going to this voltage regulator? Right, well when I go onto here and here, I've got 5.9 volts. Now, what have I got coming out of here? Nothing. 5.9. 0.5. Now, let me kill power a second. Let's see if that's linked to that. Yes, it is. So, we've got 5.9 going in, but then we've got nothing happening. Now, is this grounds here? Let's see if this is grounds. Yes, it is. So that's ground, and that is the positive there. So this must be the output here, and we haven't got anything here, have we? Why not? Is it being pulled down? Have we got a short somewhere? Let's have a look. So this is the ground. No. I think I'm going to look up this one online, see if I can find it. This one here is a voltage regulator. So if you look up here, I believe this is it. BL8503. And it says here that it is ideal for, it can greatly improve the natural life of batteries. So it's a low power consumption, low dropout voltage, 3-terminal regulator. And it says that it does an input range of 1.5 volts to 10 volts, an output range of 1.2 volts to 6 volts. So we're putting in 6 volts and yet we're only getting 0.5 volts out. So that's definitely not correct, is it? Because if it was 1.5 volts in, it should be 1.2 volts out. If it's 10 volts in, it should be 6 volts out. So 6 volts is going to be what? 5-ish? 4-ish? 4 point something? And we're not getting that. And if we have a look down here, you can see, I think that this is our one here. And we have ground. This is the voltage in. And 3 should be voltage out, and remember we're not getting anything. So it looks like we just need to change over the voltage regulator. Now I haven't got an exact copy, but I have got ones that look similar. So I've got ones that are called AMS1117 and they come in 3.3 volts and 5 volts. I'm going to go for a 3.3 volt and see how it operates. If there's a problem with it, then I can always put in a 5 volt one. The problem is the pinout on them is different. So we've got ground on the left, we've got the output in the middle, and then we've got the voltage in on the very right, and that's different because on the board currently we have ground, voltage in, and then output on the very right. But it doesn't really matter, there's plenty of space around the actual area. So what I'm going to do is I'm just going to run little wires to this one here. But obviously if you wanted to do a perfect job, you would get the exact replacement chip and then it would be as it was manufactured. But this is still going to take an input voltage and it's still going to output 3.3 volts, so it should do the same job. So I'm just removing the old one using some low melt solder, so I don't have to put heat anywhere near it because there's quite a few plastic connections and stuff around the place. And then I'm just soldering in the new one using little jumper wires so we can get it going to the right pads, because obviously everything is a little bit crossed up. Right, okay, so that's back on there now. Right, let's pop this back together. I'm just going to be looking at the pictures just to make sure I've got it all the same. And yeah, I'll start filming again just as I'm about to turn it on. Right, I've got them all wired up, the same as the photo I took earlier. So now let's plug in the battery here. So I think we're all good to go. Here goes. Fingers crossed. Excellent. Club rock. Let me get screws back in it and then finish up the video. So there we have it, what a nice little fix. One tiny little voltage regulator rendered the whole thing faulty. So I would like to play you out with some nice beats, but unfortunately I can't manage that even though this drum machine is working perfectly. So I'm going to play you out with a joke instead. Why does a golfer wear 2 pairs of trousers?
I don't know. Why does he wear 2 pairs of trousers?
In case it gets a hole in one! I'll get my coat, I'm very sorry. Anyway, that's it for this video. Hope you enjoyed it. If you did, give it a big thumbs up. Thank you so much for watching.